morning, students. Hopefully you guys are doing great, and welcome to another video from iCampSA. This one is for grade 10. We're gonna be doing mathematics, and we're gonna be doing a past paper question, and the area of focus is functions. And this paper that we're gonna be doing here is one from KZN. It was a June examination, and this paper was written in 2022. Without wasting any more time, let's get into it. So the functions were on question 3. So we have that question 3, and the statement reads as follow. The graph of f at x is equal to ax squared plus q. The graph of f at x is equal to ax squared plus q. What does that tell us? Once we see that x squared, now we know that we are dealing with what? With a parabola. And that plus q is our turning point, and also the y-intercept. Okay, and g at x is equal to mx plus c. Mx plus c is what function? That is a straight line. We are now dealing with a straight line because of that mx plus c as sketched below. The graph of f intersects the graph of f intersects the x-axis at what? At -4 and 0, and the the coordinates of b we are not given there, and the y-axis at what? At 0 and 4, which is also the turning point of f. What is the turning point in our equation? That is the value of q. So the y coordinates of the turning point is the value of q. Is what I was saying at the beginning of this video. One of the points of intersections of f and g is a. So these graphs, they also intersect there at a. What do I always say about the point where the graph intersects is that if we are ever asked to calculate the coordinates where our graphs intersect, what do? We simply equate our two equations and solve for x. Sometimes we might have to solve for x simultaneously in the case whereby you have 2 points where our graphs intersect, but in this case we're already given that the other point is -4 where the graphs intersect. Okay, so that is that. Let's get into the questions. Use the graphs and the information given above to determine the equation of g. Okay, so in order to determine the equation of g, we need to find the value of m and c. What is the value of c? The value of c is the y-intercept. It's where our function cuts the y-axis. So we can see that from the graph we are given there that the y-intercept is at 2. So the value of c is 2, and then once we have 2 coordinates, we can find the value of m because m is our gradient. So let's get into 3.1.1. Okay, so we start writing here 3.1.1. 1.1, the equation of g, the function, so the straight line function. So we said c is equal to, or maybe let's start by writing that g at x is equal to mx plus c, and c, we are saying c is the y-intercept where x is equal to 0. C is let me just say c is y-intercept. Therefore c is equal to what's the y-intercept is 2. C is equal to 2. And then next, what do we have to calculate now is the value of m, the gradient. And what is the gradient? The gradient is the difference of height over the difference of the run. So y1 minus y2 over x1 minus x2. So we'll take the coordinates with -4 and 0 as our first coordinate. So we have 2 coordinates there, which is -4 and 0, and then we have 0 and 2. So 0 minus 2, we're gonna have 0 minus 2 over negative 4 minus 0. Therefore, we're going to have negative 2 over negative 4 is going to be a half, a positive half. Therefore, g at x is equal to 1 over 2 x plus 2. That is the equation of the straight line function. That is the equation of the straight line function, of which makes sense that the value of the trirad is positive, because the x values are increasing, sorry, the y values are increasing as the x values are increasing. So the y values are going up and up while the x values are getting bigger and bigger. Okay, so and then next we have to determine the value of a and q for 3.1.2. So our q, we said, what is our q? The q is the turning point. So we are told what was the turning point. The turning point is 0 and 4. The coordinates of the turning point is 0 and 4. So therefore we know that our q is going to be what? So this one is 3.1.2. Our q is equal to 4. Our q is equal to 4. That is the turning point. We can put in brackets and say turning point and the y-intercept. Okay, and then next we have to find the value of a. Now what do we do in order to find the value of a? We have coordinates that lies on this function. First thing first is the turning point, and also the other coordinates of -4 and 0. The coordinates of -4 and 0, it also lies on the parabola. So in order to find the value of a, we're gonna say what? F at x is equal to ax squared plus q. Our q, we know, is 4. And then just by looking at the function, remember the value of a also tells us the direction that the function is going to be facing. So what we are seeing here is that this function is facing downwards. So we are expecting the value of a to be what? To be negative. But let's go ahead and solve for the value of a. So we have to substitute one of the coordinates there. Let's take -4 and 0. -4 and 0, where x is -4, y is 0, a is equal to -4 squared. What is the value of q? Plus 4. Therefore 0 is equal to a multiplied by -4 squared is equal to 16. So we're going to have 16a plus 4. We take the 4 to the other side, so we're going to have 16a is equal to negative 4. And then what do? We divide by 16 on both sides. 16 on both sides. Therefore a is equal to, what is -4 over 16 is 1 over 4 is -1 over 4. That is the value of a. That is the value of a. And what did I say? I said that we expect the value of a to be negative because our function is facing down, and that's what we see happening there. And then next, we also find the coordinates of b. So for this function that we are dealing with, we know that they have the axis of symmetry, where at the y-axis, where x is equal to 0. So the distance from O to -4 is the same distance from O to B, of which will make now b to be what? The coordinates of b are going to be 4 and 0, because it's on the positive side. So it's 3.1.3. So 3.1.3, the coordinates of b are what? Are 4 and 0, because b is simply the mirror image of the other coordinate, which is -4 and 0. Okay, and then for 3.1.4, we are asked to determine the domain and range of f. Remember that the domain we are looking at what? At the x-axis, and then at range, sorry, we are looking at the x values, and then for the range we are looking at the y values. So for the function of it's 3.1.4, for the function of f, the parabola, the domain as we can see that the function goes from negative infinity up until positive infinity, we're gonna say the domain x is the element from negative infinity to positive infinity. So the function exists for all the x values, and then for the range, we know that y is the element. Our function starts from when? From that positive 4 going downwards. Any values above 4, whether 4.0, 1, and 4.5 or 5, any value above 4, our function doesn't exist. So that's where our function stops. From what? From negative infinity. And remember that when we are writing the domain and range, we always start with the smallest value. So the smallest value here is the negative infinity. So it's negative infinity up until what? Up until 4, the value of 4. And then remember to use square bracket because 4 is also part of this function, so it's included. So that square bracket represents what? Inclusivity. Okay, and then for 3.1.5, the equation of kx, if k is a graph of f reflected about the x-axis, so we have to reflect the graph of what now? Of f about the x-axis. So in order to reflect the graph about the x-axis, what do? We simply introduce a negative sign. So 3.1.5, so for 3.1.5, what is the equation of f? It's f at x is equal to negative 1 over 4 x squared plus 4. Let me double check. Yes, that is it. And then we are told that the graph of what? Of k at x, the graph of k at x is equal to negative f at x. So what is f at x? F at x is negative 1 over 4 x squared plus 4. Therefore the graph of k at x will be negative multiplied by negative. We're going to have a positive 1 over 4 x squared minus 4, and that will be the equation for the graph of k at x. Since it's reflected about the x-axis, so we expect, if we were to sketch this function, we will expect it to be facing upwards like that. That would be the graph of k, and then it would have the turning point at negative 4, as you can see there, at negative 4. Okay, and then next, one value of x, we have to determine one value of x for which f at x is equal to 0. So one value of x for which f at x is equal to 0. So basically we are looking for the x-intercepts where f at x is equal to 0. So we can either go with negative 4 or 4. So either one, because those are the x-intercepts for the graph of f. Okay, so this one is 3.1.6, 3.1.6 is what? So we're looking for the x values. X is equal to 4. We can take x is equal to 4, and let's just put also x is equal to negative 4. Those are the two values, but you only need one, so you only need one. Okay, and then next, determine the values of x for which f at x is greater than g at x, given that a is the coordinates of a is what? 2 and 3. Coordinates of a is 2 and 3. So we're looking for all those values of x whereby the parabola is greater than the graph of g, the straight line. So when we're looking for the values whereby the graph, one graph is greater than the other, we're basically looking for all those values where the graph of f is above the graph of y. So it is above the graph of g. So we can see from here up until -4, the graph of G is below, the graph of F is below the graph of G, because here's the graph of G, it is above. Okay, and once we get there at -4, right up until A, the graph of what now of F is above the graph of G. And then when we get at A, once again the graph of F goes below the graph of G. Okay, so you can see that, okay, it's all those values of x between -4 and what, and A, which is 2. Okay, so we have to write that. We have to now write that, because we're only looking for the values greater than, not greater than or equal. So we're gonna have what, this is 3.1.7. We're gonna say where x is greater than -4, but x is less than what, less than 2. Let's write it in the proper form. We say x is greater than what, is greater than -4, but x is less than 2, and then we can erase this, and that will be your answer. This one is 3.1.7. okay, then yeah, that should be your answer. Those would be the values of x whereby the graph of F is greater than the graph of G. Okay, and then next we have question 3.2. Question 3.2, what do we have here? So it's a sketching question. The function of h at x is equal to k to the power of x. We are seeing x as an exponent there. So what do we know about that? What does that tell us? That tells us that we are now dealing with what? With an exponential function. Because the variable x is at where? Is an exponent. Plus q. Okay, is described with the following properties. That q, we know that it also represents what? The q represents is what? Is our asymptote. Q is the horizontal asymptote for the exponential function. Yes, q is the asymptote. Okay, let's describe with the following properties. Okay, k is greater than 0. So k is positive. What does that tell us? And then k is not equal to 1. Okay, understood that. Because if k is equal to 1, then we're essentially going to have a straight line, because it doesn't matter what value we raise k to, there's going to be no change, because 1, if k is 1, we can say 1 to the exponent 1000, we're still going to get 1. Okay, and then h at 0, where x is equal to 0, is equal to -7. What does that tells us? That where x is equal to 0, the function of h at x is -7. That is our y-intercept essentially. And then where h is 3, where x is 3, the function of h is 0. So basically this is our y-intercept, and then here where h is 3, h at 3 is equal to 0. So the function of h is equal to 0. That will be our x-intercept. intercept. Okay, use the information provided to sketch a neat graph of h. Okay, I think we can sketch the graph. Let's start by drawing our x and y axis. This would be your x-axis and this would be your y. Okay, let's now calibrate our axis. 2, 4, 6, 8. 2, 4, 6, 8. I will just use the intervals of 2. So I can have a -2, -4, -6, -8, -2, -4, -6, -8. It's 2, 4, 6, 8, 2, 4, 6, 8. Let's start by sketching our asymptote, which is -8. That will be our horizontal asymptote, where y is equal to -8. Okay, and then what's next? We have 2 points. We can just go ahead and sketch those. Where x is equal to 0, we have -7. That will be our y-intercept, and then the x-intercept is where x is 3. So we can see that this is gonna be an increasing function. Yeah, it's gonna be a function of that nature. It's increasing very quick, so just wanted to pass by. Yeah, I think that's one better. Okay, and that is how our function is gonna look. So those coordinates that we have here. First one is 10, y-intercept is 0 and -7. We can include them, and then we have 3 and 0. Okay, and that is our function is gonna be of that nature. Okay, so that is that, and that is how you go about sketching your function. Let's go ahead to the next question. For question 4. Okay, so for question 4, what do we have here? F at x is equal to 12 over x. X is the denominator now, the variable x. What does that tell us? It tells us we are dealing with a hyperbola plus 3. The value of 3 is what? Is our horizontal asymptote. Okay, and then what else do we see? We see that 12 over x is essentially positive, so the function is gonna be in which branches? The branches of the function is gonna be in which quadrants? It's gonna be in quadrant 1 and 3. Okay, if we were to be asked to sketch the function. Then for 4.1, what do we have here? Write down the equations of the asymptotes. So the equations of the asymptotes, in the asymptotes are just the straight lines, are gonna be what? Gonna be x is equal to 0. That's the first one. X is equal to 0 is your vertical asymptote. And then next, we're gonna have y is equal to 3, and that will be your horizontal asymptote. Okay, and then next, determine the equation of G, the axis of symmetry of F with a positive gradient. So the equation of G is gonna be what? Since it has been shifted up, this function has been shifted up by 3 units, we simply have to go to the equation of y is equal to x and then add the asymptote. So 4.2, the equation of the axis of symmetry with the positive gradient is gonna be what? Y it's gonna be y is equal to x plus 3 because it has been shifted 3 units upwards. That's the equation of the axis of symmetry with a positive gradient. If we were to be asked to write the one for the one that has a negative gradient, we are going to have a what? A negative x. Okay, and then for 4.3, sketch the graph of f and g, okay, on the same set of axes, indicating all intercepts with the axes and asymptotes. Okay, with the axes and asymptotes. Okay. Okay, so what we'll do next, let's find the intercepts. I think that's gonna be the easiest way. Let's find the intercepts for the function of f. First thing first, f at x is equal to 12 over x plus 3. So if we were to find the y-intercept, no, we don't have the y-intercepts because the y-intercepts essentially is where we have the asymptote. So we're only going to have the x-intercepts where y is equal to 0. So we're going to have 0 is equal to 12 over x plus 3. We put 3 on the other side, so we're going to have 12 over x is equal to negative 3. Negative 3x is equal to 12. We divide by negative 3 on both sides. Therefore, x is equal to negative 4, and that is our x-intercept. X-intercept. Okay, I forgot to write that. For x-intercept, we let y equal to 0. That is the x-intercepts for the function of f, where x is equal to negative 4. Okay, and then next we only have the x-intercepts for the function of f. Let's go ahead and find the intercepts for the function of g, which is y is equal to, let's just say g at x is equal to x plus 3. That's the function of g, which is the axis of symmetry, so x plus 3. Okay, and then for x-intercepts, we let y equal to 0. So we're going to have 0 is equal to x plus 3. Therefore, we're going to have what? X is equal to negative 3. And then for the y-intercept, we let x equal to 0. We let x equal to 0. Therefore, we're going to have y is equal to 3. Y is equal to 3. It cuts there at the asymptote. At the asymptote, yes. Okay, and then let's sketch our function. Okay. Let's sketch our function. And these are your y-axis, these are x-axis. And we see we have 3, we have I think we can calibrate it with 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 2 3 4 5 negative 1 negative 2 negative 3 negative 4 negative 5 1 2 3 4 5 negative 1 negative 2 negative 3 negative 4 negative 5. Okay, and there we have it. Okay, now it's time to sketch. Let's start by sketching the asymptotes for the hyperbola, the function of f. What is the horizontal asymptote? Is y is equal to 3. So we're gonna have an asymptote here. Asymptote here at y is equal to 3. And then what else do we have for this function? We have an x-intercept. We have an x-intercept at x is equal to what? At x is equal to -4 here. At x is equal to -4. It would have actually looked better if we used 2's. Yeah, if we use 2's, but anyway, it's okay. And then because this function has been stretched a lot, okay. And then next, what else do we have? Yeah, for this function, I think basically that's all we need. We can sketch our function. We know it's gonna be at quadrant 1 and 3. It's gonna be of that nature. Okay, this is our function, and then the other branch will be here. That's the other branch. Okay, and then let's go ahead and sketch the function of g at x. What do we have there? We have x-intercept at x is equal to -3 here, and then y-intercept at 3 there. Then you take the ruler, you simply join the 2 points. And that then becomes the function of g. This one we call it g at x is equal to x plus 3. And then the other function is what? F at x is equal to 12 over x plus 3. Yeah, we have labeled, indicating all intercepts with the axes and the asymptotes. Okay, that's now labeled the intercepts. Here we have -4 and 0, and then here we have -3 and 0, and then we have 0 and 3. Yes, okay, and there you have it, and this is how your function will actually come out. Okay, this then I believe marks the end of this video. Make sure you like, subscribe, and share this video with your classmates or your siblings or your kids, and until we meet again, I wish you good luck and good studying.